Okay, I just want to finish up the double integrals over general regions. This is part 2. I'm only limited to 15 minutes on my video, so that's probably a good thing. And finishing my example up. This is example 2, right, from page continues on page 1004. All right. So again, we have this region and now we were treating as a type 2 region. So we wanted to finish up by stating what our region is. Again, x, y. And this time, the restrictions for y are going to be these constants instead of the x being the constant restrictions. Oops, that's a 4. That's a 4. All right. And then we've got x being restricted by the function 1/2 y and square root of y. That means we can find the volume of this double integral by doing an iterating integral from 0 to 4 this time and 1/2 y to square root of y. That's x squared plus 4y squared dx dy. So this time we're integrating, dy. We're integrating the inside with respect to dx first and then dy. And if you follow it along, you'll get 216 over 35, which we got originally using the type 1. So this is the type 2 way to do it. So again, you may get a general region like this that's neither type 1 nor type 2. You can manipulate it and make it a type 1 or type 2 and do the iterated integral, solving the volume and so forth for this. So there's multiple ways to go about doing this. There's plenty of examples in the book. So I'm going to move on from there real quick. And the last thing I want to mention is there are these properties of double integrals which are very similar to the properties of single integrals. But one property I just want to make sure that you pay close attention to, which I think is pretty obvious, but we'll just talk about it real quick. So if we're trying to integrate the double integral and we're trying to find what this is a 1. So we're integrating over the region D, dA. That's really just going to give you the area of the region D. Right? I think that really makes sense. If you got let's draw this. Z, Y, X. And say we have some general region D in which we've got our Z, which equals 1. Here, 1. And we're trying to find the volume. Well, we would generally be trying to find the volume of this solid here. Really, that's just going to end up being the area of D. Because you're multiplying the area of D times this height, which is 1. So you're going to end up with just that area. All right, so go and check out the other properties. Those are on page 1006 and 1007. All right, and that's done for that video. Good luck on 15.2.